Hey, and welcome to a lesson on consecutive integers. So here we go with our learning targets. Today, you will know what a consecutive integer is, and you'll be able to write and solve equations involving consecutive integers, okay? So let's get right into it. Remember that an integer is a whole number, but we're including both positive and negative. Also, 0 is considered an integer, okay? So decimals or answers that end in fractions should not happen whenever you're solving these questions. It has to be one of those positive or negative counting numbers, all right? And then the word consecutive just means following in order. So if you were to count, you're always counting in consecutives, whether it's 0, 1, 2, 3, 4, or maybe you count by twos, 2, 4, 6, 8. That would be evens, or maybe you count by odds, 3, 5, 7, 9, or maybe you count by threes, 3, 6, 9, 12, 15. As long as there's a pattern and it's consecutive, therefore we'll be able to determine what's missing, okay? Let's kind of get into some more background and some more understanding of what this means. So consecutive integers are simply a list of integers that increase by 1 unit between each or by the same amount. And we're going to see that in a little bit. So let's fill in the pattern here with consecutive integers. If we had 2, 3, blank 5, something, something 8, I think it's pretty easy to see that it's going by 1. So it's 2, 3, 4, 5, 6, 7, 8 in an order, consecutive, okay? So what would happen if we didn't know what the first term is? So kind of like this situation where it's n, right? So if it was 2 here, notice how it went up by 1, but then to go from the original 2 to 4, it's up by 2, and then from 2 to 5, it goes up by 3, and then up by 4. So it's increasing by 1 each and every single time using the starting value. So it's n plus 1, but then it's n plus 2, and then it's the first number plus 3, and then it's the next number and 4 more. In order for it to get bigger, we need to keep going up 1 every single time. So if we were to substitute in a number for the variable, let's call it 2 again, okay? And plug this in and see what happens. 2 plus 1 would be 3, right? And then 2 plus 2 would be 4, because it's now 1 larger than the one before. 2 plus 3 would be 5. 2 plus 4 would be 6. And I think you get the hang of what we're trying to accomplish here. That's going to be very important later on. All right, we can also talk about consecutive even and consecutive odd integers. So let's fill in the pattern here. It starts 5, 7, 9. So those are odd numbers and they're going up by 2. So 5, 7, 9, 11, 13, 2 more, 15, 2 more, 17. All right. Now, again, consecutive integers could include negatives. These happen to be even numbers, and they are getting larger. They're getting closer to 0. So negative 10, negative 8, negative 6, negative 4, negative 2, and then eventually 0. Okay? So let's talk about how we could write an expression if we didn't know the first number of a consecutive even or consecutive odd set or group. So to go from a consecutive even or odd, we have to add 2, right? So each time we go up, we're adding 2 more and not just 1 more. Whether it's odds or evens, it's always 2. And the reason is if you start with an odd and add 2, you'll get an odd. And if you start with an even and add 2, you will get an even. All right? So looking at this, if the first number was n, the next number would be 2 more. And then it's got to increase by 2 again. So after that, it's 4 more. And then it's going to increase by 2 again from that number, and it's going to be 6. So when we're using that first number, notice how the pattern creates a consecutive even or odd just by adding 2 or 4 or 6. All right?